Hi, thanks for joining me. Today I've got another integral video for you. I want to evaluate this integral here. So it's an integral from 0 to infinity of log, and then inside the log, x to the x minus 1 power, all divided by x cubed minus 1 dx. So a really crazy and weird looking integral involving x to the x sort of in the log and dividing by something, and the integrals are 0 to infinity, which always is good fun. Okay, and the way I'm going to be doing this is actually without any complex analysis, and the solution I'm going to provide is both really neat and beautiful, but also kind of annoying, because it kind of only works in this case. Anyway, if you want to have a go at evaluating this integral, pause the video now and give it a go for yourself, and I'm going to jump into a solution. Okay, so the first thing I want to do is actually write this integral in a different way, just using some nice properties. So the first thing is, I want to bring this x minus 1 outside the log, and I can do that just by dropping the power. So that's one of the standard log properties. So bring this x minus 1 from the exponent just out to the front here, like so. Okay, so this is just x minus 1 times log x, all divided by x cubed minus 1 dx. Now this x minus 1 over x cubed minus 1, we can actually simplify that. A few different ways you can do it, but just I guess you can check for yourself. X cubed minus 1 is just x minus 1 times x squared plus x plus 1, and you can just see that by expanding the brackets or using sort of the geometric progression formula on x squared plus x plus 1. Okay, but you can see this, so of course x minus 1 divided by x cubed minus 1 is, if I divide through by x cubed minus 1 and bring this to the other side, I get that 1 plus x squared plus x plus 1 is equal to x minus 1 over x cubed minus 1, like so. So I can replace the x minus 1 over x cubed minus 1 with this guy here. So I have that I is equal to the integral from 0 to infinity of log x divided by x squared plus x plus 1 dx. Okay, so far I haven't done any integrating. I've just essentially replaced the integrand using a log trick and a sort of nice factorization / geometric progression trick. Okay, so I is equivalently this integral here, and now what we want to do is just sort of focus on this integral here. Now, as I said at the start, the solution I'm going to provide is kind of neat, but also kind of annoying, and the reason for that, or I guess we'll see in just a second, let me just show you. We're going to work with this integral at the bottom now, and do a u substitution on this guy here. So the u substitution, just sort of as if by magic, is u equals 1 over x. Okay, so the reason, it's not quite clear why I've chosen this u substitution here, and I'm not sure how you would sort of intuitively see it. I guess there are logs in there, and then there's also, when you do the derivative of this, you're going to get an x squared, which kind of works nicely with the denominator. Yeah, but apart from that, there's no real sort of intuition as to why you should do u equals 1 over x. It's kind of a leap of faith. Let's do it. U equals 1 over x. So of course that means that x equals 1 over u, and then that means that dx is equal to minus 1 over u squared du. Okay, so we can write this integral now, I, as the integral from, well, when x equals 0 from the positive side, because this is just 0 plus, we get u is equal to 1 over 0 plus, which is infinity, or positive infinity. Okay, and when x is infinity, we get that u is 1 over infinity, which is 0, like so. Now log x is just log of 1 over u, which is the same as log of u to the power of minus 1, and then we can bring that minus 1 out to the front. So this is just minus log of u, oopsie daisy, minus log of u divided by, now x squared is just 1 over u squared, x is just 1 over u, and then 1 is just 1 of course, and then dx is minus 1 over u squared du, like so. Okay, and now we can use this u squared, multiply through here, so this whole denominator now becomes 1 over u squared times u squared, which is 1, 1 over u times u squared is just u, and then the 1 that was there times u squared is just u squared. Okay, now this minus 1 here we can get rid of, and that will swap the limits of integration. So let's just get rid of this as a whole, and that swaps the limits of integration. So now I is the integral from 0 to infinity of minus log u divided by 1 plus u squared. But if we just look at what we had I is here, it's kind of exactly the same thing, except with x replaced with u, and we've got this minus sign here. But now remember, x and u, they're just dummy variables in the integral. It doesn't really matter what we call them. So in fact, this guy here is the same thing as if I were to replace all the u's with x's. Now if I bring this minus sign out front, this is just minus, now this integral here which of course is just I. So we have that I is equal to minus I, adding I to both sides, then dividing by 2. Of course, that means that 2I equals 0, so that means that I equals 0. Okay, so we haven't actually done any integration, we've just done a u substitution and essentially shown that the integral we had is also equal to minus the integral we had, and thus the initial integral must be 0. Okay, again, as I said, the solution is kind of neat because the u substitution is quite cute, how it all works out, but it's annoying because it's not really clear how we're supposed to choose u equals 1 over x. I've just sort of told you, do u equals 1 over x, and then it just works out quite nicely. Nonetheless, I think it's a pretty cool integral, and I hope you have enjoyed this video. I'll catch you in the next one. Have a great day.